Hi everyone, and thanks for tuning into my presentation here. My name's Luke Hargreaves. I'm a Senior Solutions Architect at Amazon Web Services, and my presentation is called Building Sustainably on AWS. Now, a lot of people ask me, what does sustainability mean? And the official definition is the ability to meet the needs of the present without compromising the needs of the future. Now that's a bit to unpack. So what I'll do is I generally tend to reverse it. And the best person that I've found to provide a quote to reverse it is David Attenborough. Now please have a look at this and read through it just for a second. We can't cut down rainforests forever, and anything we can't do forever is by definition unsustainable. Okay, so this quote really resonated with me, and there's a personal reason for that. I grew up in far north Queensland. It's the oldest rainforest in the world at 180 million years. The Great Barrier Reef also is in far north Queensland, and it stretches all the way down to the middle of Queensland at 2,300 kilometres long. It's durable country, which are the people that live there. Now, I saw David speak in Brisbane, and he said that the Tablelands was his favourite place in the world. So I like to think that this quote in some way relates to me. And that thought pretty much shaped the way my life went after that. So I started studying sustainability after seeing these things and understanding that this is what was happening with the world. And when I was studying it, I found that there was a definition of sustainability that had 3 pillars in it. Now these are the 3. Now I've put them in this order for a reason. Environmental sits right in the middle. Okay, so environmental is the most important. Without the environmental part of these 3 pillars, the other 2 can't exist. So AKA planet first and profits then people. There's no real order to it apart from planet first. Okay, and after there's obviously social. So social is the health impact of communities and understanding how to improve community health. We talk about the difference between progress and change and what defines that. But often the economic argument is overlooked because it's thought of that sustainability somehow compromises economics. In fact, that's not the case. In a Euclid survey in 2018, 35% of baby boomers said that sustainability was important to them. So that's a relatively big, chunk of people saying that sustainable products are important to them. 48% of Gen Xers, that's a jump. 48% said that sustainability was important to them. And 52% of millennials said that was important, sustainable products were important to them. So as you can see, there is a trend. The younger the generations, the more important sustainability is. And that's because they're inheriting the earth that we're giving over to them. Okay, so that's the reason for those stats. Now also I wanted to talk through there was a survey done in 2020 by IBM. So of the 80% that said sustainability was important, 70% of those people would pay a premium for sustainable products up to 35% more. 35% more premium for knowing that a product is more sustainable. Okay, so that's a pretty powerful marketing and economic argument for sustainable products going forward. But how can sustainability be broken up? How can we know, I guess, what baseline we have and how we're getting better at it? For this reason, in 2015, a set of goals were come up with, the Sustainable Development Goals in Rio de Janeiro by the UN. Okay, at that time I was volunteering for the UN because of what I was saying before, David Attenborough being one of my favorite people. And what my job was at that time was to put out the word about these goals. Now, there are 17 goals. Very, very important goals across the board. Obviously, from our point of view, from a data center point of view, goal number 7 is really important. But they're also really important overall because they spur companies around the world into action. Now, a good stat that I like to talk about is 95% of global top 250 companies now formally report on their sustainability. So they have what we call CSR or ESG reporting in their board reports at the end of the year. Now, this is a huge difference to what was going on before the SDGs came out. That means reporting is important to investors, as important to investors as it is to consumers. Now, Amazon itself aligns to these goals, particularly goals number 7, 9, 11, 13, and 17. Now, the reasons why we do that is just it's the right thing to do, and it also gives us a way of measuring our progress. Another quote. This quote's from Fuji Cho, who's the president of Toyota Motors, and have a read of that. They'll become a necessity. Environmentally friendly cars will become a necessity. Now, this is a man who's talking about a business model that is going to be completely disrupted, completely turned around for him. And he's not afraid. He's not afraid to change. He's not afraid to make changes to his business overall. But think about this. What's Toyota also responsible for? All the developers out there. Think it's responsible for Scrum, for Agile, Lean, all the cool working ways, the ways that we use as developers that we just take for granted now and are just words that we hear in our head. Oh no, we need to do it in this way. Toyota invented those words. So obviously when Toyota speaks about the future, we listen. So in order to understand that, a mental model I like to use is similar to the security or shared responsibility model. Okay, so anyone familiar with AWS knows that we have a security shared responsibility model, so hard to say. But basically what that means is we take care of security at a certain level and you take care of security on the cloud. So of the cloud and on the cloud. Okay, so what I've done is I've pulled together a set of patterns for sustainability. At AWS, security is job zero, and so too should sustainability be. So think about this. AWS will take care of things like energy mix, cooling, water management, supply chain, longevity, architectural guidance, for example. Those are the things that we will take care of. What you take care of as a customer are things like right sizing for your environment, responsible SLAs, end user impacts, minimizing data impacts, modernization of your fleet. So have a think about that as I go through what AWS is doing. Specifically now, these are the numbers. So this is the bottom part. And the first number I wanted to draw attention to was the one right in the center. Running in AWS data centers, you're running at 88% lower carbon footprint. That's the highlight, okay? When we pull all other things together. So the number 3.6 times more energy efficient. The numbers 2025 path to renewables. What we're talking about here is we're talking about density. We're talking about energy mix. We're talking about renewable energy mix basically coming in on a path to being 100% renewable. We also, as a company, Amazon has committed to be net carbon zero by 2040. That's 10 years ahead of the Paris Climate Agreement, and we call that commitment Amazon's Climate Pledge. Now that Climate Pledge is set up originally for Amazon, but it now has a number of signatories to it who also commit to being net carbon zero by 2040. Alongside that Climate Pledge is the Climate Pledge Fund. Now that's a $2 billion fund that customers around the world who are doing innovative, sustainable projects can apply for and send their ideas in for potential funding through the Climate Pledge Fund. I think another thing, Amazon has just invested in 100,000 electric vehicles across the US. Now, when I just say these numbers, they don't really make a lot of sense, but 100,000 electric vehicles, there's 110,000 vehicles in the US Postal Service. So that kind of means we could replace the US Postal Service with electric vehicles. That's the scale we're talking about here. What about renewable energy? We've got like 6.5 gigawatts of renewable energy across the world. So when we put that into context, that's 127 global renewable projects. Amazon is the world's largest corporate procurer of global renewable energy now, for that 6.5 gigawatts, but that's enough to power 1.7 million homes. That's residential homes. So the population of Sydney is what, 6 million? But there is 1.8 million residential homes. So we could almost serve the entire residential population of Sydney just with renewable energy. That's putting that into context. We also maintain a data set. We call that the Amazon Sustainable Data Initiative, ASDI. And we have 76 different data sets on sustainable projects that you can download now and use with your own data projects to augment things like climate, fires, floods, those sorts of things. So please have a look and check that out, pull that in. Right, that's what we're doing. What about what you can do, right? So what I've done here is I've broken it into 4 sections. Basically, I've broken it into how you can deal with your users, how you can deal with software, how you can deal with hardware, and how you can deal with deployment. So I'll start off with users, put it into 3 sections. SLAs. When are your users using your products? Are they on late at night? Are they on during the day? Think about how you can scale during the time that your users are actually online. Or even better, think about the SLAs that you have. Okay, you don't need to have 10 servers running at 100% all the time, right? Think about how you can scale vertically up and scale horizontally across. When we talk about that, we talk about horizontal scaling as being far preferable because you can scale out and in and use far less energy based on that. Okay, so horizontal scaling over vertical scaling, remember that one. Using as little amount of energy, and we'll get into that with hardware later on. And making sure that it matches to your users' SLAs, which feeds into patterns. Utilization, data access patterns, device usage patterns. Just make sure you know your users really well. In order to do that, I want you to start using Amazon CloudWatch dashboards. Those dashboards can give you metrics into the usage patterns that you need. And this will be a recurring theme as well. Monitoring will be a recurring theme along this. Staff. Staff are often not thought about when we're talking about users. Staff are also users of your IT. And are they being provisioned with too much like over-the-top hardware, or is it something that you can virtualize, for example? Is it something that you can maybe fit the hardware that they need and use as thin clients? So think about using Amazon Workspaces, for example. That's something that you can use as virtual machines that customers can then use to be able to do better upgrade cycles. You don't need to replace as much hardware. You'll get the latest software on top of it if you keep it upgraded, right? And it's also a managed platform underneath. So have a think about those virtual machine technologies for your users. Secondly, software. This is actually my favorite one because people don't think about it as much as they probably could. It doesn't actually make sense from a sustainability point of view, but having done this now, it completely makes sense. From a starting point, design, okay? So think about how your design is. We have two different types of major designs in software. One is queue-driven, and the other is polling. Okay, a queue-driven thing basically wakes up when it needs to do some work. A polling system sits there running until it needs to do some work, okay? So as you can imagine, a running process takes up energy. Something that just wakes up, it wakes up and it starts doing its work and then it goes back to sleep again. That's why I say use queue-driven architectures. They scale really well. And you can also basically cache information in there and use the buffers and caching to make it far more efficient from an energy perspective. It also means you can choose the instance types you need basically for consumption, which leads into data, okay? When you're consuming instance types, you need to think about how much data you're using and the data that you keep or throw away. Do you need all the data that you have? Now, the classification policy you have, do you keep, I don't know, like a day's worth of data for 5-minute increments, and then a week you store it at 10-minute increments, and then a month you store it at an hour-long increments, and then you put it into something like archival, something like Amazon Glacier, right? So think about whether you need all that data. It's a mythical 7 years generally that people say around whether they need that data, but is it public, private? Can you get it again? Can you just download it again, or is it something that is specific to your company? So have a think about how you can do that. And the third one is algorithms. This is my favorite one of all of them. There's been a lot of development, particularly in Northern Europe, around algorithms that are more sustainable. And what does that mean? A sustainable algorithm is an algorithm that uses far less compute cycles to get to where it needs to go. So for example, let's say you have a tree-based searching algorithm that throws things in half and then searches and searches and searches in that way. There are newer vector-based searching algorithms that are much faster, and they use a lot less energy. So please look at the APIs that you're using. Look at the example libraries that are being built, particularly around sustainable libraries, which are available right now, and are starting to be woven into the latest versions of the biggest languages we'll be using. So we'll be using Java, we'll be using TypeScript, we'll be using .NET Core, for example. Those languages are all starting to be woven in with these sustainable libraries in the latest versions. So please keep up to date with your versions of your libraries. Make sure you're using efficient code. Oh, one other big thing, crypto libraries, anything that you're encrypting, use the latest ones of those because they've become extremely efficient over the last few years. And these algorithms are particularly compute intensive if you're not using them in the right way. All right, hardware, we're here. Minimal hardware, makes sense, right? We've said it forever, minimal hardware. Being able to know when your users are going to be online, when they're not, forecasting, being able to know capacity, being able to scale. Now we have a number of services, Amazon EC2, AWS Lambda, Graviton, I'll talk about in the suitable section. But making sure that you're using them in the right way and you're using the smallest number of them, okay? Understand your workloads. This is another point for your CloudWatch dashboards, understanding your workloads, okay? Density. Now, we can provide as dense a service as possible, but whether you use it or not is completely up to your choice, okay? We have a number of patterns on a lot of different levels for you to use our services. So for example, starting with EC2, we already have extremely dense virtual machines in a data center. And a good way to think about this, a typical enterprise data center will be used potentially at 20% capacity. Now this capacity is basically saying that compute workloads are running on 20% of the servers, but 20% of the servers are also actually being used. So you're using energy for 100% of those servers. That means 80% aren't being used. A typical AWS data center uses up to 60% capacity. So that 40% jump and 40% unused is through a couple of reasons, but it's primarily through density. So if you can think about it, do a top-down serverless approach. So use AWS Lambda to start with because that is the most dense that you can use. Then start using containers and then potentially start using EC2 instances. Think about it in reverse, okay? And finally, with hardware, use the right hardware for the problem you're solving. A really great example of this that we've seen recently is in machine learning, okay? So we've seen people using really optimized, highly optimized compute instances for their machine learning, or particularly even GPU instances. But they're not the most efficient for a lot of machine learning projects. For that reason, we brought out FPGA instances that you can use. And they typically tend to cut down machine learning time by quite a lot, up to 80%. So have a think about using FPGAs, for example. Save those GPUs for using things like transcoding or media, like this video. Okay, save it for that. And then, if you're wanting to use just general web serving products, or if you're wanting to use smaller microservices, have a think about the recently released AWS Graviton. Graviton 2 actually now we're up to, which is able to be running a whole lot less energy with the same compute performance and a lot less cost. Okay, so this is where we talk about the cost argument coming into the sustainability argument as well, and I'll get into that again in one of the examples with our customers. Deployment, this is the final one. Now, often when we think about deployment, we don't think sustainability. And this was one I had trouble with understanding how does this relate to sustainability? But it really does. Now, firstly, testing. Did you ever think of doing testing as part of your test cycle for sustainability? So for example, testing how many compute cycles your code's using, or testing how much energy the instances you are spinning up is using and optimizing that. We optimize everything else, so let's do it for testing, right? And also making smaller improvements of deployment, smaller, tiny changes, rather than one big change and not knowing where your energy consumption has changed, okay? Secondly, environments. This is interesting. Another part of analytics, another important thing, understanding your own utilization, but and this is not common knowledge, but AWS already has a number of regions that are currently offset and using renewable energy. Think about using those regions for some of your dev workloads, for example. This is Oregon, Stockholm, Ireland. If you have dev workloads that you could use and you can put up with a little bit higher latency, you can be running in there and already have a relatively good sustainable prospect for your customers and for your reporting at the end of the year. Now, we already have a target to hit 2025, so if you are building on AWS already, that target will be hit by 2025. But the issue is right now is we are working on making sure that we can get it up to 2025 and getting our customers to build as sustainably as possible. Thirdly, update. The most recent code libraries that we have are the more sustainable ones and are the ones that have the latest libraries in them. So please don't forget to update to the latest software, update to the latest operating systems, and think about adopting more efficient technology. This isn't just a sustainability argument. This is an argument just in general to make sure you're running on the latest versions. It'll help you across all the other architectural pillars. It'll help you be more secure, more reliable, more performant, more cost optimized, and it'll make your operational excellence far better. And for more information around that, you can see the well-architected framework. This is a slide of a lot of the customers that are doing work on us, sustainable projects specifically. Now, I put this slide here not to make ourselves look cool, although we love what our customers are doing. What I put this slide in for is to highlight that with so many customers, comes a lot of feedback. So processes within AWS iterate very, very quickly. We see a lot of new things with our customers. Our customers are very, very good at giving us feedback. So you'll see a lot of changes in use cases over the next few years. What are these use cases? General sustainability use cases we see most often are around facilities management, manufacturing processes, transportation and logistics, predictive maintenance, fleet management, smart agriculture, monitoring and forecasting, and smart cities. But what I want to do is I want to dive deep a little bit into three of these use cases: agriculture, transport, and cities. And I'm going to try and localize it a little bit just to give us a good perspective. So the first one, love this project, absolutely love it. It was done in Byron Bay. It's Nestlé's chain of origin. And what it aims to do is make transparency for consumers of the origination of the raw products of their coffee. And I guess what that means is you can see where the coffee is coming from. Now, how is this important in the sustainability argument? Okay, so if we can see where the origin of our coffee is coming from, if we can trace that, we can also make sure that that coffee has been sourced sustainably, and there is a circular economic benefit for everyone in the value chain there. That's really, really important. So that's a community version. Now, remember the 3 pillars I talked about at the start? Economic, environment, and social. Nestlé's chain of origin fits into the social pillar. But what about the economic one that I referenced midway through the presentation? Qantas. Qantas has a project called Project Constellation. And Project Constellation is basically using machine learning to optimize their flight paths in real time. Now, they're using currently AWS products, EC2 instances to run these machine learning projects. And what it's doing is, because it's optimizing the flight path, what it's doing is it's using less fuel. And if you're using less fuel, it's a whole lot cheaper. Huh? Get the economic argument, whole lot cheaper. And also, it's more sustainable because we're not releasing as much CO2 into the atmosphere. So that's how a sustainable idea can also fit into an economic argument as well. And this is just one example of the many economic arguments I could put through. Finally, Vector. Vector is a company in New Zealand that is building a new energy platform. And what they're doing is they're using IoT and analytics to optimize where the energy is coming from and optimize where the energy is going to. So that means a more efficient grid, a better way of knowing where your energy is coming from. Is it coming from renewable sources? Is it clean? Is it dirty? And also making sure it's getting to the right place when energy is needed. So just like our servers are on demand, this energy is on demand. And they want to revolutionize the New Zealand energy industry doing that. So I wanted to highlight them. Fantastic company. Now, so what can we do? Well, in order to think about what we can do overall, and having a second to read it, it really sunk in for me now. This was a then 16-year-old Swedish woman. Now, you remember when I was talking about how as the generations get younger and younger, this becomes more and more important because it's the world that they're inheriting. It's also the world that we are trying to give. So please have a read. The eyes of all future generations are upon you. So we all have the power to change the path the world's currently on. All of us do. So what are we going to do about it? And how are we going to do it? All right, so thank you very much for watching this session. I appreciate you staying until the end. If you enjoyed it, please don't forget to fill out the survey and give us your feedback. Thanks very much.